Okay, so in this tutorial, we are going to go from looking at a graph and then making a quadratic equation that models that graph, which is the opposite of what we just were doing, where I gave you an equation and you made the graph and then you identified points. So we are going to actually look at the second problem on the worksheet that I gave you, just so I can go back and forth between the steps and the picture. So looking at this, we only see a picture. We see an x-axis and a y-axis and some coordinates, but we have this picture laid on top of it. Note the grid lines, that each grid line is a meter. So that's a meter there, that's a meter up. So we're told to write a quadratic equation that models the path of the gymnasts. So in order to do this, we're going to follow these steps. We're going to start by identifying the x-intercepts. We again want to write it in factored form, so we're going to write the standard factored form, which is y equals a x minus p x minus q. Where remember, it's the minuses because factors are opposites of our x-intercept solutions, roots, or zeros. So indeed, for step one, we are finding those x-intercepts on the graph. So here's the x-axis. Here's where the gymnast crosses the x-axis, here and here. So there's my points. So I'm going to write zeros and list them. So this is 1, comma 0, and then 2, 3, 4, 5, 6, 7, comma 0. Now, as it says in your steps, one is your P and one is your Q. It doesn't matter which one is which. So we are going to plug the x-intercepts into the factored form of the equation. We're going to notice that we still need an a value to complete the equation. So if we look at this, y equals a x, like I said, here's a p and here's a q, so minus the 1, x minus the 7. The problem is an equation, in order to plug it into a calculator, you only need an x and a y being empty, the inputs and the outputs. Well, why is this still a variable? Well, it's because we have to find a, so we have a proper equation. So how should we find a? Well, if we look at our steps, to find a, we must plug in an x and a y to solve for a. Is there an easily identifiable x and y on the graph that we can use? Yeah, there is. The vertex. The vertex is that top point or bottom point of the quadratic. We're going to plug in the vertex's x in the x spot and the y in the y spot. So then we have a as the only variable. So let's label our vertex now. Here's my vertex. Here's the very top of the gymnast flip. And that's located at 1, 2, 3, 4. 1, 2, 3, up 3, 4, comma 3. Here's my x. Here's my y that I'm going to use to find a. So I'm going to put the 3 in the y spot. Remember, we're finding a, so we don't have anything in for a. 4 minus 1, 4 minus 7. Following along with the steps, we are now going to solve for a. And we're able to solve for a because here's all numbers, and then a is the variable. So 4 minus 1 is 3. 4 minus 7 is negative 3. 3 times negative 3 is a negative 9. We still have the a. We want to solve for a, so divide both sides by negative 9. We get a equals negative 1/3. So now we found our a. And according to our last step, we now have a P, a Q, and an A. So we're going to insert them in their rightful spots of the factor form. Again, it's written here. Yes, x and y should stay variables because we need an x and a y to have a quadratic equation. The only reason why we filled in x and y's here was so we could find what a was. But in the end, our equation should always have a y and an x. So here's our y. Our a we found to be 1, negative 1/3, x, and then our p we chose as 1, and then x minus 7. So now that means here is my equation that models the flippy guy. So if I was to type this into the calculator, type this into Desmos, I should get the same shape that models the trajectory of the gymnast.